On the engine warning display, read the title of the failure. Notice also the check attitude on both PFDs, indicating that there is a difference in the aircraft attitude displayed to the pilots. There is no ECAM page associated with the ADIRs, so the cruise page remains on the system display. The attitude crosscheck is carried out by comparing both PFDs to the standby horizon. In this example, the first officer's PFD differs from the captain's PFD and the standby horizon, and is obviously the one at fault. Having identified which PFD is faulty, the attitude heading switch should be selected to the faulty side. Switch attitude heading to First Officer on 3. IR3 is now supplying the First Officer side, and aircraft attitude on his PFD is back to normal. Check attitude indications have disappeared, as has the ECAM attitude discrepancy. The status page is displayed for review. The green message advises us that everything is normal. Now, clear the status page. Status is not displayed on the ECAM memo section since the status page is empty. The only reminder is the green switching panel memo, indicating that the switching panel is not in the normal configuration. On the engine warning display, read the title of the failure. Notice on the PFD the speed, Mach, altitude, and barometric indications are lost. The ECAM checklist requires that you switch the air data to the Captain on 3 position. Switch air data to Captain on 3. The failure flags have disappeared. ADR number 3 is now supplying the captain's instruments. ECAM now requires you to switch off ADR number 1. Switch off ADR number 1. ADR number 1 is now off. A consequence of switching off ADR number 1 is the failure of the GPWS. Now switch off the gpws, the ground proximity warning system. Now we can clear the ADR fault. Clear the nav ADR fault. The status page is displayed for review. A green message advises us that the approach capability is degraded to Cat 3 single only. You can see in the INOP Systems column that ADR1, Cat 3 Dual, and the GPWS are inoperative. After confirmation, clear the status page. ECAM complete, screens normal. Let's see now a demonstration of an in-flight radio altimeter abnormality. On the engine warning display, read the title of the failure. As there is no associated procedure after review and confirmation from the pilot flying, clear navigation. The status page is displayed, showing inoperative systems and aircraft information. With only one radio altimeter, Cat 3 is unavailable, and the failure of radio altimeter 1 causes the loss of the GPWS. After review and confirmation from the pilot flying, clear status. You are flying an approach manually with radio altimeter 1 still faulty. On the engine warning display, read the title of the failure. As there is no associated procedure, after review and confirmation from the pilot flying, clear navigation. The status page is displayed, showing inoperative systems and aircraft information. With both radio altimeters faulty, both autopilots are lost in approach, as well as the auto callouts. After review and confirmation from the pilot flying, clear status. The ECAM system display automatically reverts to the cruise page, and the status reminder is displayed on the engine warning display. Blank MCDU screens with amber fail annunciator lights and the red map on the navigation display indicate that a double FMGC failure has occurred. Here we will focus on navigation, so we will consider that all actions concerning the other systems have been performed. As the MCDUs are no longer available for navigation and nav-aid tuning, the only navigation capability remaining is radio aid raw data. For this, we need to use the standby nav-aid tuning capability of the radio management panel. The activation of the standby navigation is achieved by pressing the navigation key on either Radio Management Panel 1 or Radio Management Panel 2. Select Standby Navigation on Radio Management Panel 1. The guard is up. Continue. Select the navigation key on Radio Management Panel 1. The green navigation light illuminates to indicate that Radio Management Panel 1 is now in the navigation mode. We have selected the navigation mode for you on Radio Management Panel 2. Note that the green navigation light is illuminated. For nav-aid tuning, Radio Management Panel 1 standby navigation keys are associated with VORDME1 and ADF1, while Radio Management Panel 2 keys are associated with VORDME2 and ADF2 if installed. New aircraft equipped with a global positioning system do not have any ADFs installed. Either Radio Management Panel 1 or 2 can tune the ILS. As an illustration, we will tune an ILS. Select the standby navigation key. The standby navigation key is now illuminated. Now select the ILS key. The standby navigation ILS key is now functioning. The active window is now showing the last memorized ILS frequency, while the standby course window is displaying the last memorized ILS course. Notice also that the selected VHF radio light is now extinguished. We will tune a different ILS. Press the transfer key. The standby course window is now displaying the current ILS frequency. Select ILS frequency 108.9. Press the transfer key. The new ILS frequency is now tuned. We will adjust the course. Select ILS course to 145. The new ILS course is now set. The tuned ILS is ready for the approach. The setting of the other nav aids, frequency, course, is done in the same way. Note that if an ADF receiver is selected, pressing the BFO key will activate the beat frequency oscillator. Note when a RMP is used to tune an ILS DME, the PFDs do not display the DME distance. To use the RMP for communication, you must deselect the standby nav mode by pressing the desired VHF key, VHF 1, 2, or 3. Any nav aids using standby nav mode will remain tuned. Do not deselect the nav key, as this will cause the standby nav tuning system to shut down. In case of failure, specific flags can disappear on the DDRMI, Digital Distance Radiomagnetic Indicator. In case of radio magnetic indicator internal failure or power supply loss, all flags are shown.